Hey guys, this is Sergey, and you're watching Dissecting the Code. Today, I want to continue a topic that I've started in one of the previous episodes, where I covered the abstraction in .NET 10. And this time, we'll talk about the delegates. The delegates is essentially a callback, and it's one of the fundamental .NET abstractions. And as any abstraction, the delegates do have the overhead. But .NET 10 drastically removes the cost of using the delegates by using the de-abstraction. In C# we use lambda expressions for creating delegates, and depending on the body of those lambda expressions, the code generation might be different. So let's benchmark them using any extension method. So the first case is any static value, where the delegate only captures static context. Then we have any instance value benchmark, where the delegate captures the instance variable. And then we have a case where the delegate captures a local variable. And as the baseline, we're going to compare this with a for each loop. We're going to compare the benchmark results between .NET 9 and .NET 10. There are a few interesting things here. First, the allocated bytes is different. So let's compare the any local variable. For .NET 9, it used to be 80 bytes, and now it's 24 bytes. And for any instance value, where the delegate was capturing instance field, the amount of allocations dropped from 64 to 0. And the time drops as well. And in .NET 10 case, the fastest benchmark is the delegate that captures instance value, and we're going to cover why. Let's see the code generation by using sharplab.io. So the first case is when the lambda expression captures a static context. In this case, instead of generating a static method, actually the compiler generates a singleton. It used to be a static method, but then the code generation changed at some point because this is a bit more efficient. We have a class C with this generated method that is equivalent to our lambda expression. And we have a static func that is cached, so it's going to be initialized only once. Now let's change it to instance method. So once we change it, we can see that now instead of generating a different class, our lambda expression is lifted into an instance method. And then the func is created every time. And if we change it to capture a local variable, the code generation changes again. Now we have a generated display class with all the fields that our lambda expression uses. And again, our method now creates a display class, sets the context, and creates a func. Let's ignore the static case and let's focus only on two cases, when the lambda expression captures a local variable or instance fields. As a reminder, we have a drastic drop in allocations. One way to see the actual allocations is to essentially profile the code. And it's possible to profile the benchmark by using those attributes. Unfortunately, if we'll try to run the benchmark, we'll see the observer effect essentially. In order to profile the application, we need to set some flags. And as you can see, this drastically affects the duration, but what is more important, this disables all digit allocations. So in this case, we can see that the number of allocations is exactly the same between .NET 10 version and .NET 9 version. And another unpleasant thing is that just to save this profiling session, it takes almost 5 minutes. Instead of using benchmarks that will warm up the code and run the actual benchmark, we'll do this ourselves. So we'll have two methods, warm up and profile. They're exactly the same, and the idea is that we will call the warm up, and then in the loop, we'll call our benchmark methods 1 million times, and that will allow the JIT to apply all the optimizations to those methods. And then when we'll call the profile method, all of those methods would be optimized. Let's look at the results. So this is .NET 9 case. And as you can see, we have any local variable benchmark that allocated two types, func and then display class, and any instance only allocated the func. And in .NET 10 case, we see only one allocation, only any local variable allocated a display class, and we don't see any func allocations. Let's compare this side by side. So we have .NET 9 and .NET 10 cases. In .NET 9, any local variable allocated func and display class, and in .NET 10, only display class is available. And in case of any instance value, we have a func here and no allocations in .NET 10. And now those benchmarking results makes more sense. It means that the delegate size is 64 bytes, and this is the exact difference between .NET 9 and .NET 10 cases. Let's look at the benchmark results closely once again. How is it possible that link any method outperforms the manual for each loop? This is done by optimization in enumerable.any that was added in .NET 9. Essentially, it was spanified. This is the source code of enumerable.any. It has a few null checks, and then it tries to get a span out of the source. As of right now, only two types are supported. It's an array and a list of t. And we can do this spanification right now. Let's add another benchmark. And we'll use asReadOnlySpan helper method that will use collection marshal that is available only in .NET 5, or otherwise it will create an array. But in this case, it doesn't really matter because we're not going to compare the full framework version. And now, as you can see, the for each case is comparable to any instance value case. They're roughly the same 13 milliseconds. And in case of .NET 9, this is the fastest way. But it's super important to understand that link is essentially the same as the for each method without any delegates. How the JIT achieves that? To see the JIT output, you can annotate your benchmark with disassembly diagnoser attribute. And once the benchmark is done, you can see all the disassembly in the MD file. The JIT output is quite convoluted, but essentially, JIT was able to enlight enumerable.any invocation and lambda expression, and essentially generated the code that we handwritten manually. And if we compare the loop bodies, they're exactly the same, only the register names are different. The JIT de-abstraction in .NET 10 is able not only to improve the enumerables, but also the delegates. In this case, the JIT can stack allocate the delegate and inline them in some cases. And here's the recap of the results. In case of any extension method, if the delegate captures only the instance field, the code generation will be very optimal. It would be the same as for reaching over a span obtained from a list with inline delegate if the delegate is small enough. And in practical terms, it means that if you have a hot loop that calls any method a lot, you can eliminate all the allocations if your lambda expression only captures an instance fields. And even if it captures a local variables or parameters, the amount of allocations drops by 64 bytes, which might be substantial. And it also improves the speed by roughly 60 or 70%. But in reality, actually the drop of allocations is something that I'm looking forward the most. That's it for today, guys. Thanks for watching, be curious, and see you next time.